get some good space. Where is the gas? This part is gas here. I think I can't show. Yeah. Are you seeing this? This part is the gas and the piston. We do have upper piston and lower piston. What are the various forces that are acting on it? We'll try to indicate various forces that are acting on it. So what is the area of cross section of this piston? Let it be A1. And I'll bring some other contrast color. Area of cross section of this be A2. Mass of this be M2. Mass of this be M1. Okay, this is what the string. Let's see what all. Here air is present. Here also air is present. Then air will exert a force P0A1. Then the gas will exert a force PA1. Tension in the string T. The weight of this M1G. Agree this? Tension, the weight of this M2G. Atmospheric pressure force P0A2. The gas is present here. Here it will exert force P into A1. See, go back to fluids. That's all here. Here water present will exert a force. Pressure into area here. But sir, like a pressure should increase with the depth. Anybody wants to answer? Pressure here should be P1, here should be P2, but pressure you're taking same because we know pressure increases depth. Go back to KTG. The pressure at steady state, the pressure at all points in the gas will be same. But sir, pressure with depth, what is this length? Even let it be 10 meters, still the pressure will be same. Only if it comes of height of 100 meters, 200 meters, kilometer, then pressure is going to change. All our KTG problem, the pressure inside the gas at all points. If I say pressure of gas, where? At all points. If I say temperature of gas, at all points. Okay, this temperature, no, T0, I'll write it. Tension, let it be T0. Able to understand now? So this what students will trouble. You'll try to go for P1A1, P2A2. P2A2, it is. What to do now? So what is the question? What is the information given? Let's see that. The difference in cross-sectional area of two pistons is delta S. So what is delta S? A1 minus A2. The masses of piston. The mass of pistons are M1 and M2. For larger and smaller, find the temperature. Okay, this M1 plus M2 equal to, let it be delta M. Okay, no needed. Okay, this will be sufficient. Okay, now let's for upper piston. For upper piston, what are the forces that will be acting? PA1A minus P0A1 minus M1G minus T0 equal to 0. Agree this? Now for lower piston, P0, okay, the PA2 minus M2G minus M2G, okay, sorry, plus M2G minus P naught T2 minus T naught equal to 0. Upward forces minus downward forces. Let me write it in order. Upward should be positive, no? So P naught A2 plus T naught minus PA2 minus M2G equals 0. Let me add equation 192. Adding 192. PA1 minus PA2 A2 minus A1 M1 plus M2G equal to 0. A1 minus A1 is greater than A2. So therefore, so this is delta S, P delta S. Let me write delta M. What is delta M? For our convenient purpose. So this equal to P naught look at the pressure of gas. Is it a constant or variable? P naught will not change, delta M will not change, G will not change, delta S will not change. So pressure of gas will be constant. Okay, now after this, what is telling? Find the temperature by which the tube is raised so that the pistons will be displaced by a distance L. So now I'll supply heat. Pressure of gas is constant. So what all heat is supplied, it will be converted into rise in temperature. Now in what action the pistons will move? Will it move up or down? Because if I supply heat, pressure constant. So let's go for the formula. PV equal to nRT. Find the temperature by which the tube is raised so that piston will be displaced by a distance L. Pressure is constant, pressure will not change. So as I rise temperature, volume will change. So delta V is equal to NR delta T. I think this is what our idea. By how much temperature should be incremented so that let me push it here. Yeah. So that the pistons will move. Tell me like a pistons will move up or down. Anybody? If temperature increases, volume should increase. For volume to increase, piston should move up or down. Who wants to answer?
Up, sir.
It should up, no, then only volume will increase. So therefore, the piston should get displaced upward here. So what is the increase in volume? What shall I write increase in volume? Anybody wants to write increase in volume? A1 minus A2 into L. 1 mole, no? So as it is 1 mole, I'll take it out this. Delta T. So finally, what is delta T is equal to P what is P into A1 minus A2 equal to this much P naught A1 minus, okay, we have here, no? P A1 minus A2, we can write it as equal to this much of P naught delta S plus delta mg. Okay, this much should be the rise in temperature. So how much the rising temperature depends on L. How much that pistons will undergo. Both will, or they'll move opposite, or they should move in same direction. Both pistons will shift upward. And what happened to distance between pistons will remain same because they're connected by string. No, string should be taut. So from where there's pressure, the molecules will be coming and colliding here. Again, you should not lose that idea. Continuously, the molecules will be colliding here. Like this, I'm showing that spot. So the molecules are colliding because of this pressure Pa2. Molecules are colliding P1. So molecules will collide with the side wall. Yes, they'll collide here. We are bothered on the piston. That's why we are thinking in terms of pressure into area will be the force exerted by the gas on the piston. So I want to calculate force on this wall. Yes, you know pressure. So calculate this area. That will be the force exerted on side walls. Similar to fluid statics. Okay, I'll slide down. The same thing, what we had find the displacement of separator after a long gap when gas on the two parts of cylinder are in thermal equilibrium. You have to work out the same. I discussed statically. Here I brought it as a numerical. Okay, can you work out this? Let me go for the next one. Let me see somebody chat. Why A1 minus A2? There is a given no data. There's a data given. Delta S equal to A1 minus A2. Okay. The difference in cross-sectional area of two pistons is given delta S. Okay, read this question.